Okie dokie. Here we go. We've got a couple more things going on here. We're going to do some more factoring. But first, you see this little picture here. Hey, look at me. Hee 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 hee. Factoring. Woo woo woo. Who's that little guy? That's me. Hee hee hee. All right. Two more approaches to factoring quadratics with integral coefficients. We're going to look at a couple more ways to do the same thing that we were doing before. Alright, so we're doing the same thing, we're still factoring. I'm going to show you a couple different ways to do it. Alright, so here's a simplified factor. We're going to do a simplified factoring listing. Here, we're going to use a sign of the constant term to decide if we're looking for a sum or difference only. If it's a plus, we're looking for a sum. If it's a minus, we're looking for a difference. Okay? So we're going to factor this guy. We're going to do a half U factorization for this guy, a full U, and then we're just going to look to see which sum or distance gives us the B. We're trying to find the B. For instance, let's take a look at this guy. 32. My n squared minus 4n minus 15. Well, factor the 32 half I did a half U. 132, 216, 48. A full U, I'd have to put 8, 4, 16, 2, 132. So I just do a half U over here. A full U for this guy. 115, 3, 5, 5, 3, 15, 1. I'm not going to worry at all about signs yet. Okay? I'm just going to say, alright, I look at the absolute value. This guy's 4. I'm looking for a difference. Which difference gives me 4? So I check the inner outers till I find that difference of 4. 32 and 15. The distance between 32 and 15 is not 4. Some 60 something in that? No. Some huge? No. Gigantic number? No. I'm looking for just a distance of 4. Go to the next set. 16 and 30? No. Looking for 4. This is only going to be 10. It's what, 48? No. 16 times 5 is ridiculously large. That's small. Big. Small. Too far away. Not 4 away. So I go to final, the last one. 8 and 15 times 4. 8 and 3, 5 times 4. Ooh, what's this one? Let's see. 8 times 3, 32. 20, nope. 40, 12, nope. 8, wait, let's go back. 8, 15, oh, nope. So basically when I'm looking at this, I think none of these work. So it's unfactorable. What? How can that happen? Wait a minute. 32, 15, wait. 68, It's got to be one of these. 8 and... No. Oh, yeah. Oh, yeah. Duh. 8 times 3 is 24. There it is. Oh, man. It's my morning brain. So I have 24 and 20. The difference is 4. So now I just have to figure out where to put that sign. Here we go. I got 20. I want this to be negative, so there's 4 left, so I need to put my sign. It's either going to be here or here. So I'm going to put it right here, so I get my negative 24 and 20. So here we go. How do I do this now? I'm going to write 4n, 8n, minus 3, positive 5. Alright, here we go again. Trying to get that negative 11 out of these factors. Let's check them. 6 and 5, nope. What? Nope. Oh, I'm adding. Phew. So I check here first, check the C term, right? Look at the sign. I'm looking for a sum. 6 and 5. Nice. 6 and 5 is 11. I'm done. Sweet. Sweet. Alright, so it's going to look like this. I have r squared, p squared, rp, so I know I'm going to have 1r. I'm going to have 6r. And over here I'm going to have, oh, what's the sign on this is negative, so minus, minus. Minus 1p, minus 5p. Let's double check. Negative 6pr, negative 5pr makes that good. 6r squared, 5p positive, 5p squared. Good. Nice. I'm moving. It's working. It's working, dude. Alright. Now there's another one. Here's another sum product approach. This approach breaks a linear term into a sum. The middle term, the B term. See this term? We're going to break it into a sum, then we're going to factor the left and right. We're going to factor by grouping. To find the sum, we have to look for another sum product. So basically, here are the steps. First, we multiply these two numbers. Okay? We're going to multiply A and C. Take that number and say, what's this? Which one's sum is B and product is this? Then we break the B term out into those and factor by grouping. Okay, what do I mean? Well, here's an example. All right, here we go. I'm going to take this guy here, this guy here, 3 and 2, and I get 6. What two numbers sum is product is 6 and sum is 7? How about 6 and 1? There we go. So I'm going to rewrite this 7x as 6x plus 1x, because these are my magic numbers. 6 times 1 is 6, 6 plus 1 is 7. So 3x squared plus 6x plus 2. There we go. See that? Now what do? I do my factor by grouping. I split this thing in half, I factor everything out of this side, and something magical happens. Yes, I said magic. Let's take a 3x out of there, end up with an x plus 2. Plus, what's the most I can take out of here? Just a 1, I guess, because I'm really not taking anything out. And now I notice, ooh, isn't this great? Check this out. When you're looking at this right here, you could think, pretend that this was 3xm plus m. You'd factor the m out of this, wouldn't you, and write m times 3x plus 1. Well, here's your m, right? So we're going to write m. We're factoring this out, and what's left? The 3x and the plus 1. So this is another way to do it. The other way, we could have done 3, 1, 2, 1 and figured that out that way, but this is just another way to do the same thing. Okay? Another cool way. Let's do one more. Or 2 more. Alright, 4y squared minus y minus 3. So let's look at this. 4, negative 3 is negative 12. So now I'm saying, what two numbers multiply to get negative 12, add to get negative 1? Well, how about, let's see, 4 and 3. How about negative 4, positive 3? My magic numbers. Let's check. Product is that, sum is that. Good. So now I'm going to rewrite the middle term with these. So I'm going to write 4y squared minus 4y plus 3y minus 3. Notice that these are the same expressions. They're equivalent. Sweet, dude. Now factor out what I can here. I can take a 4y out of this guy, and I get y minus 1. What can I take out of this? A 3. Y minus 1. The y minus 1 is common, so I'm going to factor that guy, y minus 1, times what's left on this side? 4y. What's left over here? Plus 3. Sweet, dude. Alright, I think we have time just for one more. Using this method again, I get negative 8k squared plus 6k plus 9. Let's do it again. What do I have here? Doodle-doom, doodle-doom. 9 times 8. Oh man, it's too late for this stuff. 72. So I'm saying, what numbers multiply to get negative 72 and add to get 6? So I think of 72, geez, 12 times 6, that kind of pops up. And oh, yeah, look at that there. Yes, the difference is okay, good. So how about positive 12 and negative 6? Let's look. Their product's this, their sum is this. Good, so I'm going to rewrite this k term, the linear term, as a sum of these guys. So negative 8k squared plus 12k minus 6k plus 9. Look at the left side, factor out everything I can. I know a k is coming out and a 4. What do I get? Negative k squared here. Negative 2k squared. 4k goes into that 3 times plus 3. What can I take out of this guy? Let's take out a negative here. I don't like having this here. So what I'm going to do, watch what happens when I'm going to factor the negatives out of these guys. Let's take these negatives out. I'm going to take a negative 4k out of this. When I take it, because I just want to show you what happens when you take a negative out. We didn't have to. When I take a negative 4k, I'm saying negative 4k times what equals this? Times just positive 2k. Now watch, I want to do negative 4k times what equals this guy. Right? What do you get? Positive 3. I'm going to take a negative 3 out of this guy, and what am I going to get? K plus 3. Sorry, 2k plus 3. The next thing I have to do is factor this 2k plus 3 out. It's going to be 2k plus 3 times 2k, negative 4k minus 3.